Unit 1, Lesson 4, Part 2. Example number 3, this is on selecting procedures for determining limits. Our first one, the limit as x approaches negative 4 of 2x squared plus 7x minus 4 over x squared minus x minus 20. I see this as possibly being something that I could factor. I notice that in the denominator, if I use direct substitution, this is my denominator only, I would get 20 minus 20. I would get 0, division by 0. So it's important that I factor, if I can, to see if possibly we could cancel something and there's a hole, and then there would possibly then be a limit. Because if there's a hole, and it's just like a pothole, if your function is going and then there's a hole but it keeps going, this is called a removable discontinuity or a point discontinuity. And the limit will exist. Okay, because as you approach it from the left and as you approach it from the right, it's going to be going to the same value, okay? You could also have an open circle, but this would be considered a non-removable jump or jump discontinuity. So you have to be careful. You can't just look for an open circle, okay? The open circle has to go, the function has to continue going, and then you have like a pothole right there where it's like a bump in the road, because that's going to be where a limit exists. So, okay, we are going to try and factor this. And if I put a 4 here, that's going to give me 8. And a 1 here, that's going to give me 1. I need a positive 7, so a positive 8 and a negative 1 will give me that positive 7. And the negative 1 times positive 4 gives me the negative 4. So I have factored the numerator. This one, a negative 5 and a positive 4. When I multiply, I get negative 20. When I add them, I get negative 1. So that one works. And then I see that x plus 4 cancels. So that does remove my division by 0 issue. So now I'm going to take and I'm going to use substitution to calculate what the limit will be. Negative 8 minus 1 over negative 9. So negative 9 over negative 9 will be positive 1. So that means positive 1 is the answer to my limit. It also means that there is a hole at negative 4 positive 1, right? That's just extra that you don't need to know right now. But that is, what is happening here in this function whenever we do this. Okay. Next one. If I put 3 in, I get 9 plus 3 is 12, minus 12, I get division by 0. So what I would like to do, and notice that I'm rewriting limit as x goes to 3 every single time until I actually substitute. So right here is when I didn't write limit because I was substituting, okay? But I have to here. And I want you to remember for this one that a cubed minus b cubed equals a minus b times a squared plus ab plus b squared, okay? And that we can look at this as my a is x and my b is 3. So I can say that this is going to factor to x minus 3 times x squared plus 3x plus 9. And then my denominator, x and x. How about a positive 4 and a negative 3? When I multiply, I get negative 12. When I add them, I get positive 1. And I can see that my x minus 3's cancel there. So that leaves me with the limit as x approaches 3 of x squared plus 3x plus 9 over x plus 4. And now I can use substitution. Notice I did not write the limit this time, and I will be looking for this on the quiz. So please make sure that you are paying attention to it. So 27/7. And again, there's a hole at 3. You know, this is just, you know, the stuff that we did last year. And so my hole is going to be at the point 3, 27/7. Number 4, now the least common multiple method for complex fractions, because if I put 0 in, I'm going to get 1/4 minus 1/4, 1/4 minus 1/4, which is 0, and I can't have division by 0, right? I can't have 0 divided by 0. I can't have anything divided by 0. So what I'm going to do is I'm going to say I'm looking at the denominator of everything. So this actually has a denominator of 1, x over 1. This 4, this x minus 4. So my least common multiple to get my common denominator, and I'm going to write that as x over 1 so that you can see it, 1/4 plus 1 over x minus 4. I'm going to multiply by the common denominator, 4 times x minus 4 over itself, 4 times x minus 4. When I do that, this is just going to become, you don't need to worry about that 1 in the denominator, right? Because there wasn't anything that cancels it, and it was just a 1 anyway. So I go ahead and say, okay, that's 4x times x minus 4. But this is a binomial, okay? This right here that I just put I'll put it around here. This, come on, pen. Yeah, my pen doesn't want to work. This is a binomial. And so this is going to get distributed. And like I said, it does not want to work for some reason. This is going to get distributed. And right? And to that one. So when you do that, my 4's are going to cancel for the first one. So I'm left with x minus 4. 1, really, times x minus 4. On the second one, my x minus 4's are going to cancel. And I'm left with just plus 4. 1 times 4. So now, limit as x goes to 0. I've got 4x. You don't want to distribute, because look what happens here. I'm left with x minus 4 plus 4, and those cancel. And limit as x goes to 0, I've got 4x times x minus 4 over x. Now, these x's are going to cancel, and I wouldn't have seen that had I distributed. If you would have distributed that 4x, then you wouldn't have seen that you had canceling, and you would have not gotten your division by 0 to go away. But that little thing right there just allowed me to get my division by 0 to go away. Now I'm able to substitute 0 for x, and I get negative 16. Okay, that's called the least common multiple method, because you looked at all of your denominators. So all of your denominators here, and then figure out what your common denominator is. So my common denominator is going to be 2 times 2 plus x. So I have to multiply by a fraction that equals 1. So I figure it out. I looked at, I looked at this one, and this one. And I said, okay, those are this right here is my least common multiple, which is my common denominator. But I had to write it over itself because I needed that fraction to equal 1. Okay? And now I need to put parentheses around this. And of course that one's fine. But I've got limit as x goes to 0. Now, distribute, and the 2 plus x's cancel. I'm left with 1 times 2, which is 2. If I distribute here, my 2's cancel. And I've got negative 1 times 2 plus x over 2 times 2 plus x. I'm sorry, 2x times 2 plus x. I almost forgot to multiply my x times my 2. Right there, multiply that x times that 2. Limit as x goes to 0. So now I've got 2 minus x over 2x times 2 plus x. Remember, do not multiply through this denominator. The 2's cancel. Limit as x goes to 0, I've got a negative x over 2x times 2 plus x. Now I can cancel these x's, which that is what saves me and takes me out of division by 0. So I've got negative 1 over 2 times 2 plus x. Now I can use substitution. Put that 0 in for x, I get negative 1 over 4. So that's your least common multiple method. You have to make sure you're multiplying by a fraction that equals 1. So that means the numerator and denominator need to be exactly the same. All right, example number 5, the rationalization technique or conjugate method. The technique of rationalization can be used to find the limit when there is a radical in the numerator or the denominator. So the graph of g of x equals the square root of x plus 2 minus 1 over x plus 1 is shown at the right. And then we want to find that limit. Well, as you're approaching negative 1, you know that limit's going to exist because, look, it's going to approach from the left and it's going to approach from the right, and whatever this, value is that you follow over, whatever that y value is, that's going to be the answer to my limit. Right now, if I put negative 1 in, I'm going to have division by 0. So I know I'm going to have to do something to this function to algebraically manipulate it so that I can figure out what this limit is. And so we are going to rationalize because I see the square root right here. And so I'm going to take the conjugate of the square root. That means the exact same first term, but I'm going to change the sign of the second term. So instead of minus 1, plus 1. That's the conjugate of this. And I have to multiply by a fraction that equals 1. So I'm multiplying by that over itself, right? So that this has to be 1, okay? Now, on these limits, the trick to this is that when you've got your binomial, right? So I started out with a binomial that had a root in it. This is my binomial right here. This is what I found the conjugate of. So this is my conjugate. Right here is the conjugate. I found it by taking the first term of my binomial and then change the sign of the second term. So the binomial times its conjugate, you want to multiply. So I'm going to multiply the square root of x plus 2 times the square root of x plus 2. I get x plus 2. Then my middle term, I've got negative 1 times the square root of x plus 2 and positive 1 times the square root of x plus 2. Those are my two middle terms. They go away. They cancel out. And then I take my negative 1 times my positive 1, and I get negative 1. The other binomial down here, the x plus 1, is getting multiplied by that conjugate because we had to have a fraction that equals 1. Do not multiply through. Do not multiply through on that. Because when we simplify this numerator, so I'm going to simplify positive 2 and negative 1, I get positive 1. Notice that since I didn't multiply through, my x plus 1s are going to cancel now. And that is what gets me away from division by 0. Because now all that's left is this. And I don't have division by 0 anymore. I can put my -1 in for x. And that gives me the square root of 1, which is 1. So 1 over 1 plus 1, that gives me my 1/2. So it kind of looked like that was 1/2, but we didn't know for sure. But it was 1/2. And so I'm approaching 1/2 from the left, I'm approaching 1/2 from the right as I approach -1, so my limit is 1/2. And part B, if I put 5 in, I get 0 divided by, and if I put 5 in here, 3 minus the square root of 9, so 3 minus 3, I get division by 0. So therefore, I cannot, I can't do it. I gotta figure out something else. Well, I notice that I have a square root. So this is my binomial that I'm going to find the conjugate of. So I'm going to multiply by same first term, change the sign of the second term. Okay? And then I have to multiply by a fraction that equals 1. So I have to multiply the top by the same exact thing. Remember, the one that is not the binomial times its conjugate, you do not multiply through. But the binomial times the conjugate, you do multiply through. So this is going to be a limit as x goes to 5. I'm leaving the numerator alone because that is not the binomial times its conjugate. But the denominator, I'm going to take 3 times 3. I get 9. My middle term always goes away. I've got a -3 times the square root of x plus 4 and a +3 times the square root of x plus 4. Those go away. The last thing I'll do is negative square root of x plus 4 times positive square root of x plus 4, which will be negative quantity x plus 4. Make sure you put that as a quantity so that you can remember to distribute your negative sign. So limit as x goes to 5. Again, I'm going to leave, I'm going to leave that numerator without multiplying through because that was not the conjugate. And this is going to become 9 minus x minus 4. So limit as x goes to 5. Again, leave this alone. Do not multiply it through. And then I'm going to combine my 9 minus 4. I get 5 minus x. Now, 5 minus x is very similar to x minus 5. So what I would like to do, limit as x goes to 5. I'm going to keep this x minus 5 times, 3 plus the square root of x plus 4 over, and I'm going to factor a -1 out and then put my x first and then my 5 second. That'd be a -5. Now I can cancel. So the only thing that changed was that I now have a -1 in the denominator. And if you want to, you can leave it in the denominator, or we know that if this is just a -1, we could actually bring it up to the numerator. And it's the same thing. So now if I put my 5 in, I got negative parenthesis 3 plus the square root of 5 plus 4. So negative parenthesis 3 plus the square root of 9, negative parenthesis 3 plus 3, -6. So that is my answer to part B. So it doesn't matter if you have to take the conjugate of the numerator term or the denominator term. You can still use the conjugate method. Just make sure you know what you're doing. Okay, number 6. Find each of the following limits analytically and show your algebraic steps. Okay, so now for this one, we have the limit as x approaches 3 I could actually just go ahead. I don't know why I'm rewriting this. I could have just gone ahead and done substitution right here like that. 15 plus 1 is 16. So now, can we take the cube root of 16? This is going to be 16 to the 2/3 power, right? And so the cube root of 16, well, what's 2 times 2 times 2? No, that's 8. What's 3 times 3 times 3? No, that's 27. So what we could do, since 8 is in here, we could say, oh, this is 2 times 8 to the 2/3. So this would be 2 to the 2/3, and then I can take the cube root of 8, oops, sorry guys, cube root of 8, and then square it, right? Because that's what this means. You're squaring, and then the 3 on the bottom is cube root. So cube root of 8 is 2. So this is 2 to the 2/3. Cube root of 8 is 2 squared, so that's 4, right? So these are still getting multiplied. Well, but if I have the same base, I can add my exponents. So I can actually add, oops, my 2/3 plus, and then I could make this 6/3, because 6/3 is 2. So this actually becomes 2 to the 8/3. I know that's an ugly, ugly answer, but that's what we get. That's what we get when we solve it. I guess you could also, like, there's another way to write this. And if you wanted to, right here, you could have said, instead of going to 2 to the 8/3, because either way is going to be okay, you could have said 4 times the cube root of 2 squared. It could have also been 4 times the cube root of 4. So that could have also been another way to write that. If you put both of these in your calculator, you will get the same exact answer, okay? So I just simplified 16 to the 2/3 two different ways, okay? And that would be your answer to that limit. So kind of weird, but okay. Part B, I really, the first thing I do is see that I'm going to have division by 0 if I use substitution. So then I'd say, oh, well, this is my binomial that I need to multiply by the conjugate. So this is going to be square root of x plus 1 plus 2 over square root of x plus 1 plus 2. And we have the limit as x approaches 3. When we multiply square root times square root, I get the x plus 1. Middle terms go away. Negative 2 times positive 2, negative 4. Over, remember, do not multiply through on the bottom. This one, it's the bottom. It's not always the bottom. It could be the top, could be the bottom. Depends on what you're doing. This becomes x minus 3 when I add like terms on the numerator. And then I've got that other x minus 3. So those are going to cancel. So we've got the limit as x approaches 3 of 1 over the square root of x plus 1 plus 2. I'm going to change colors so you can see the answer. Oops, thought I changed colors. Because I'm running into this other problem. But now you can use substitution. If I put 3 in for x right here, I'm going to get the square root of 4, which is 2. And so 1 over 2 plus 2, 1/4. So that was letter B. Letter C, the limit as x approaches negative 3 from the left. So I'm approaching negative 3 from the left. And a lot of times, you might be able to just use substitution, but when I put negative 3 in times 4, I get negative 12, and then my positive 12 is going to give me division by 0, so that one is not going to work. I'm not going to be able to do that for this one. what I could do is I could say, well, I can take a 2 out of this absolute value. I don't know if it's going to help us, but let's go ahead and take that 2 out. This would be the absolute value of x plus 3. And then I can take a 4 out of this, x plus 3, divide by 2, divide by 2. And I still have -3 going in, giving me division by 0 here. But I also have an x plus 3 in the top and an x plus 3 in the bottom. And this one is an absolute value, but if you remember correctly, they will cancel. But if you're putting a -3 in, you're going to end up with a negative value. So because you're coming in, how do I say that? Like if I was just looking at the function y equals the absolute value of x plus 3 over x plus 3, it's going to split at -3. So it's going to be negative going this way and +1 going this way, right? So it's going to be 1 and -1. Those are going to be the two things, and it's going to split at x equals -3. So if I'm coming in from the left, this becomes -1. So I'm going to cancel those, but I need to remember it's a -1 when I cancel it because it's coming in from the left. So the limit as x approaches -3 from the left of -x squared over 2. And so now negative times -3 squared over 2, -9/2. And letter D. I'm going to change colors again. If I'm approaching 3, let's just see if we give division by 0. This would be 9 minus 18, which is a -9, a +9. That's going to give us a 0. So yes, you would have division by 0 if you use direct substitution. So let's go ahead and try to see what we can do here. I accidentally hit that. So we've got square root of, and this one is going to be x minus 3 times x minus 3, so it's x minus 3 squared. So my square root and my square are going to go away. So limit as x approaches 3 of 4 times x minus 3 over x minus 3. So this limit is going to be 4 because those x minus 3's are going to cancel. All right, and then this one we're going to multiply by the common denominator, which is going to be x times x plus 3 over x times x plus 3. Remember, you're looking at all the denominators and finding, this one has a denominator of 1, and you're finding your common denominator. So when we distribute, and remember you're distributing because this is a binomial. So when I distribute here, my x's cancel, and I just get x plus 3. When I distribute here, my x plus 3's cancel, and I just get x. And then here, I'm going to have x squared times x plus 3. So limit as x goes to 0, this is going to be 2x plus 3 over x squared times x plus 3. Oops. And now for this one, when you get, like you tried to manipulate it as best you can, but there's nothing that will cancel. So therefore, this one's going to be does not exist. And it's going to be, you'd have to technically, like if you were on the AP exam and you didn't have a calculator, you would have to do by inspection, and you would have to look at x values like from the left would be as I'm approaching 0, like 0.001, right? I'm sorry, that's from the right. From the right would be that. From the left, we would do like 0 point, or negative, excuse me, negative 0.001. And so this would be coming in from the left, that one would be coming in from the right, and you'd want to see what happens to this 2 times 0.001 plus 3 over 0.001 squared times 0.001 plus 3. And you can see that this is going to give you a positive value. And then this next one is 2 times negative 0.001 plus 3 divided by negative 0.001 squared negative 0.001 plus 3. Excuse me. This one's actually also going to give you positive. And I don't know if you remember, but since we're approaching 0 and this x is to the second power, it's going to go up to infinity on both sides. It's either going to go down on both sides at your vertical asymptote x equals 0, or it's going to go up on both sides. We just proved that it's going to go up on both sides. So this one technically does not exist, because normally if it's doing the same thing on both sides, we put what it's doing. It's the behavior of the function. This limit actually doesn't exist, but since we know the behavior is doing the same thing on both sides, we're going to put infinity, because that is going to infinity on both sides. Okay, and now letter F. Limit as h goes to 0. We're going to have to multiply these out. I'm going to get a new color. We're going to have to multiply these out. Limit as h goes to 0, because I know direct substitution is going to give me 0 divided by 0. So I'm going to multiply x squared. I'm going to get a 2xh plus h squared. I'm going to get minus 3x minus 3h minus x squared plus 3x, all divided by h. Limit as h goes to 0. Notice that my x squared here and my negative x squared there is going to go away. Negative 3x, positive 3x goes away. So what I'm left with, every single one of those has an h in it. So I'm going to factor that h out. So notice I had 2xh plus h squared minus 3h left. If I factor an h out, I get 2x plus h minus 3. And now my h's cancel. So the limit as h goes to 0 of 2x plus h minus 3, when I put my 0 in, I'm left with 2x minus 3. Okay? And now the very, very last thing is something called the squeeze theorem. And this is not going to be the only time you talk about the squeeze theorem, but you got to kind of start getting yourself ready for it. So the squeeze theorem, basically, you see this blue function right here. This is your main function that you're trying to find something, trying to figure out what the limit is. And sometimes you have to think about, well, it lies between these two other functions. And look, as it approaches c, they all approach the same value because g of x is in between those. It's sandwiched between them. Sometimes the squeeze theorem is called the sandwich theorem. Okay, so if you see the sandwich theorem, that is going to be the same thing as the squeeze theorem. So what they've done is they've said, if your f of x is squeezed in between this function y equals 1 and the function y equals x squared plus 2x plus 2, then they want you to find the limit as x approaches negative 1 of that. Well, if I know y equals 1, right? I know y equals 1. That's just going to be this function right here. That's y equals 1. And I know that the limit as x approaches negative 1 of y equals 1 is going to be 1, because it doesn't matter you know, what you're approaching. Here's -1, and if I'm approaching it, I'm going to get 1. But it doesn't matter, you know, what it is you're approaching, you're always going to get 1 because it's a constant, okay? So now, limit as x approaches -1 of f of x, and then limit as x approaches -1 of x squared plus 2x plus 2. So what is this limit of the third thing? Because I'm looking to see if I can figure out what this is sandwiched between. And I'm going to erase this graph right here and keep going here. So I'm trying to see, is this limit sandwiched between anything that I can decipher? So I'm going to try direct substitution for this one. I'm going to try putting -1 and squaring it plus 2 times -1 plus 2. And so that's going to be 1 minus 2 plus 2. And so this actually simplifies to 1. So if this is sandwiched between 1 and 1, that means this has to be 1. So by the sandwich theorem or by the squeeze theorem, the limit as x approaches -1 of f of x has to be 1. Okay, because it was sandwiched between it. So they gave us an inequality here, and they asked us for a limit, and we chose to do that inequality on every single term, on the first term, the middle term, and the last term. Since our limits of the first term and the last term equal the same value, then the squeeze theorem tells you that that limit of the middle term has to be that value. And we have one more, and it's showing you the function here. It says, suppose f of x and g of x are boundaries of h of x, as shown on the graph below. Given f of x equals ln of x plus x squared and g of x equals e to the x minus 1, for all x in the interval containing x equals 1, except possibly at x equals 1 itself, find the limit as x goes to 1 of h of x and justify. So, my goodness, this green function here is our h of x. You can see that it's sandwiched between this blue function, g of x is e to the x minus 1, and this red function, f of x is ln x plus x squared. So, and you can see that, your, from the left-hand side, okay, so from the left, you've got your f of x is less than or equal to your h of x, which is less than or equal to your g of x. And we're going to talk about that. Oops. And then down here, I'm going to say from the right, because if I'm coming in towards 1 from the right, my g of x is the lowest. Look right here, you see how g of x is the lowest? So we have g of x is less than or equal to, then my green function, h of x, is less than or equal to, then my red function, f of x. So what I want to do is I want to look at the limit as x is approaching 1 from the left of f of x, the limit as x is approaching 1 from the left of h of x, and the limit as x is approaching 1 from the left of g of x. So I've got the limit as x is approaching 1 from the left. My f of x is ln x plus x squared, less than or equal to the limit as x is approaching 1 from the left of h of x, which they really haven't given us, is less than or equal to the limit as x is approaching 1 from the left of g of x, which they have told us is e to the x minus 1. So if I put a 1 in, I get ln of 1 plus 1 squared. So ln of 1 is 0. 1 squared is 1. We're going to see if this is sandwiched between something. And then if I put a 1 in here, I get e to the 0, which is 1. So coming in from the left, this one has to be, therefore, by the squeeze theorem, the limit as x approaches 1 from the left of h of x has to be 1. And then let's look at coming in from the right. We want to look at the limit as x approaches 1 from the right of g of x, the limit as x approaches 1 from the right of h of x, and the limit as x approaches 1 from the right of f of x. So we've got the limit as x approaches 1 from the right. Our g of x was e to the x minus 1 is less than or equal to the limit as x approaches 1 from the right of h of x is less than or equal to the limit as x approaches 1 from the right of f of x, which is ln x plus x squared. And so if I put 1 in here, I get e to the 0, which is 1. And if is less than or equal to the limit as x approaches 1 from the right of h of x is less than or equal to, if I put a 1 in here, I get 0 plus 1. That's 1. And so therefore, by the squeeze theorem, the limit as x approaches 1 from the right of h of x is 1. And now, so since the limit as x approaches 1 from the left of h of x equals the limit as x approaches 1 from the right of h of x equals 1, then that tells us that the general limit as x approaches 1 of h of x is 1. Okay, if the left-hand limit is 1 and the right-hand limit is 1, that means your general limit is 1, which is what they were trying to have us prove. Okay, and that is your end of your